Now, before we get started, are there questions over the homework? All right. What we're looking at today is function operations, operations on functions. Addition, subtraction, multiplication, division.
Good afternoon, Concord High School. Just a reminder that the PLC meeting is tomorrow, not Wednesday. Thank you.
So, you do need to write down the definition. You do not need the example. Or f plus g of x is the same as f of x plus g of x. F minus g of x is the same as f of x minus g of x.
Butterfly, come to the office. Butterfly, come to the office.
Yeah.
F times g of x is the same as f of x times g of x. And lastly, f divided by g of x is f of x divided by g of x. So you don't need the examples because it's just reiterating what it is, but we have this here. And the only other thing we could really say is that for division, that the function g of x cannot be 0, because if the function g of x actually equals 0, we're dividing by 0, that doesn't work. Some questions on this so far? We ready for the first problem? Let f of x be 3 times the square root of x, and g of x be negative 10 times the square root of x. Find f plus g of x. Now, we're not going to worry about the domain, and then we're going to evaluate when x is 4. So what we want to find is f plus g of x. Now, realistically, this is a shorthand way to say that we're going to take the function f of x and add it to g of x. So f plus g, so f of x goes first, g of x goes second. If it had been g plus f, it would have been g of x plus f of x. We get this here. Okay. Questions on this so far? Now, technically what we're going to do is we're going to plug x into f of x, which is just 3 square root of x. Because all we did was replace x with x. It doesn't change anything. So essentially we're just replacing f of x with what it equals. Plus, we're going to do the same thing with g of x, which is just going to give us negative 10 square root of x. So we have 3 square root of x plus negative 10 square root of x, because we can drop the parentheses with plus. Questions on this here? So do both of those, so 3 square root of x, negative 10 square root of x, they're like terms because the radicals are the same, and what's inside the radicals are also the same. They're both square roots. They both just have x, both square root of x. So since they're like terms, we're really looking at 3 plus negative 10, or 3 minus 10 is 3 minus 10 would be negative 7 square root of x. Because they're like terms, we're just combining those there. So f plus g of x is negative 7 square root of x. Because really all we're doing is combining like terms. So negative 3 plus 10, or negative, or not negative 3, 3 minus 10 is negative 7, so negative 7 squared of x. Questions on this first part here? Now the second part asked us to evaluate when x is 4, or really what it's saying is it wants us to find the value of f plus g of 4. We're plugging 4 in for x. Now we could go through the whole process again f of 4 plus g of 4 working all the way down, but I know what f plus g of x is, yes? Negative 7 square root of x. But we don't have x anymore, we have 4. So we're trying to find negative 7 times the square root of 4. Questions on how we got to this part? There's two ways we can do this. First way is we can look at this here and say the square root of 4 is 2. Negative 7 times 2 is, so f plus g of 4 is negative 14. Okay. We want to see the other way we could have done this. We could have typed it in a calculator. It's just straight numbers. So we could do it by hand or we can do it in the calculator. Either way, we do get to the same answer. Questions on this here? Well, that's it. We're ready for the next one. F plus g of x. Now, we're not going to really state the domain because I'm not going to focus too much on the domain for this here. College algebra will ask, they will do these again and ask for the domain. It's just what values of x work. It's very nice when both of our polynomial functions are quadratics, our cubics, our quartics. We don't have radicals because then it's just all real numbers. Now for us here, f of x is 5 square root of x. And our g of x would be so we have 5 square root of x plus negative 8 square root of x, or we could have said minus 8 square root of x plus a negative minus are the same thing. So these are like terms, yes? Radicals are the same, variables inside are the same. So 5 minus 8 is square root of x. So really all we're doing is combining like terms. Questions on how we found f plus g of x? Now we want to find f plus g of 16. So we're looking at negative 3 times the square root of 16. Again, we can do this by hand or we can do it in the calculator. Either way, we will get the same answer. Square root of 16 is 4, and negative 3 times 4 is negative 12. So f plus g of 16 is negative 12. Questions on this here? Do you feel comfortable with addition? It's kind of a nice change or a nice way to start a week off, yes? Subtraction is next. So they gave us f of x and g of x, and they want us to find f minus g of x. Well, again, this is just f of x minus g of x. F of x, in our case, we're plugging x into f of x, which just gives us 3x cubed minus 2x squared plus 5. Minus. Plugging x into g of x just gives us, well, function itself. Questions on this so far? And for the most part, except for the minus sign between them, we really haven't done anything different than addition. Would we agree with that? I mean, all the steps so far has pretty much been addition except for the minus sign between them. Now the next part is going to be very similar to addition. We could drop the parentheses around our first expression. The 3x cubed minus 2x squared plus 5 is just going to be that there. But the difference, and this is very crucial, is that we do have to apply that negative to every term in the second expression because we're subtracting it from it. We're applying that negative to it. So our positive x cubed is now negative x cubed. Our negative 3x squared is now positive 3x squared. Our positive 4x is now negative 4x. And our negative 2 is now positive 2. Okay. We're used to that. That's come up time and time again, especially with subtracting these polynomials or just subtracting any expression. Okay. Are you ready for the next step? Combine like terms. Always start with the one with the biggest exponent first. 3x cubed minus x cubed is 2x cubed. 3 minus 1 gives us 2. X squared, negative 2x squared plus 3x squared is plus, because we have negative 2 plus 3 is 1. Our term after x squared would be x, or x to the first. Well, the first one doesn't have 1, but the second one does have a negative 4x. So that would just be negative 4x. And lastly, 5 plus 2 is plus 7. So f minus g of x is 2x cubed plus x squared minus 4x plus 7. Questions on this here? You kind of like those so far? Now it did ask us to find f minus g of negative 2, yes? So all we got to do is go back through the function and replace every x with negative 2. So we have 2 times negative 2 cubed plus negative 2 squared minus 4 times negative 2 plus 7. And with these here, I would always put parentheses around the number we're plugging in. Now, for the most part, in some cases, it's not going to make a big difference. Because if you plug this into the calculator, negative 2 to the third power is indeed negative 8. Because negative 2 times negative 2 is positive 4, times negative 2 makes it back to negative 8. Plus, negative 2 squared is actually positive 4. Now, if you didn't put the parentheses around the negative 2, when you put in the calculator, it will tell you it's negative 4, because it's only going to square the 2, not the negative. Negative 4 times negative 2 is going to be plus 8, plus 7. Negative 2 times 8 is negative 16. 8 plus 4 is 12, plus 7 is 19. And negative 16 plus 19 is 3. So f minus g of negative 2 is 3. Now, you didn't have to do that by hand. You could have typed the whole thing in the calculator, and it would have told you it was negative 3. Or not negative 3, just 3. So that's it. So what do you think? Is subtraction that much different than addition? A little bit, because we have to keep track of our sign. But other than that, simplify, combine like terms. You're ready for the next one. We'll do one more with subtraction. I do need to make sure and go back and not fix this slide, but try to get it a little bit better quality focused.
Are you supposed to record?
Yeah.
Oh.
Yeah. Sometimes when I remember, I take that and put it down, so it's out of the screen. Trying to find better ways. Yeah, there's been a few times I've paused it or didn't remember to start it. There's been some times I forgot to turn the headset on. We've got all those down, and I'm hoping with the mic being down and not out, you're not getting, I think those of you who've watched it, that me exhaling, it's finally gotten that out of the audio track, so you're not listening to that the whole time. Now, but this here, f of x minus g of x, well, f of x is 2x cubed plus 4x squared minus 8x plus 4 minus our g of x, which is 3x cubed minus 5x squared plus 6x minus 9. Now, really on your homework, if you're writing this out, we could just start off with f of x minus g of x. We don't necessarily have to write f minus g of x and then split it up to f of x minus g of x, because those mean the same thing. Now, with our subtraction, our first expression, 2x cubed plus 4x squared minus 8x plus 4 is going to stay the same. But our second expression, our 3x cubed minus 5x squared plus 6x minus 9, we have to apply that negative to every single term, which makes our 3x cubed negative 3x cubed. Our negative 5x squared is now positive 5x squared. Our positive 6x is now negative 6x, and our negative 9 is now positive 9. Really, we just go through and flip the signs on every single one. And now we're going to combine like terms. So the first one we're looking at is 2x cubed minus 3x cubed. It would be 1x cubed or x cubed, and it would be negative, because 2 minus 3 would give us negative 1. Then we move on to x squared. 4x squared plus 5x squared is plus 9x squared. Negative 8x minus 6x is negative 14x. Now, luckily for most of these here, we don't necessarily have to do them in our head, because we can add or subtract the numbers in front. We can throw that in a calculator, negative 8 minus 6, negative 14. And lastly, 4 plus 9, 13. Plus 13. So our f minus g of x is x cubed plus 9x squared minus 14x plus 13. Now it's going to want us to find f minus g of negative 1. So all we're doing is plugging negative 1 into every x. So we have negative 1 cubed plus 9 times negative 1 squared minus 14 times negative 1 plus 13. Squared. And we could go through, type the whole thing into either calculator, and it'll tell us that it is 37. So we don't have to do these by hand, but we can if we want. Questions on this here? So we've gone through addition, we've gone through subtraction. Now we're going to look at multiplication. So we want to find the product of f times g of x. And we're not going to worry about the domain. Then we want to evaluate the product when x is equal to 9. Now, f times g of x is the same as f of x times g of x. We're just multiplying the two together. Now, f of x is x squared. Our g of x is square root of x. So we're wanting to multiply these two together. We're wanting to multiply x squared and the square root of x together. What do you think our product of x squared and the square root of x would be? We're just multiplying them together. Now, if it had been, we plugged it into the square root of x, yes, the square root of x squared would be x, or the square root of x squared would be x. When we multiply them together, we just stick them next to each other. It'd be the same as 2 times the square root of x is 2 square root of x. Just multiply them together. Now, the textbook takes this one step further, and we're going to look at that. Because we do have x squared times. Now, it's been a minute, because we've talked about the nth root of a to the x. And we could rewrite this as a fractional exponent, and that would be x a to the x over n. Because that's how we can split from rational exponents to radicals. And for us, we would have x. Now, since the exponent attached the x inside the radical, there's not one written. It's understood to be 1. Since it's a square root, the index, or the root we're taking, is 2. So really, the square root of x is the same as x to the 1/2, or x to the 0.5. So if you're trying to do some of the radicals, especially on the graphing calculator, you could do x to the 0.5, x to the 1/2, and get the same thing as the square root of x. But the reason they say that is because they're doing this is just to get it as a single term. When we multiply like bases, we add the exponents. So we're saying 2 plus 1/2. Well, is 5/2. So they're saying f plus g of x is x to the 5/2. Now with the multiplication, I will happily accept x squared times the square root of x. X squared square root of x. I will take that as the correct answer. Okay? Because it doesn't violate any of our rules. We don't have a radical in the bottom of a fraction. We don't have a fraction in the radical. So I think that is a perfectly fine answer. But if we do have a radical in the bottom, if it was x squared over the square root of x, we do need to simplify it kind of as we did here, going down there. But because it's multiplication, both of these work. Questions on this here? Well, we do have the second part that we do need to evaluate this when x is 9. Now I'm going to do this twice. Because we can say f times g of 9. Well, the first one we got was x squared times the square root of x. So 9 squared times the square root of 9. 9 squared times square root of 9 is 343. Okay. Now we also said that this is the same as our 5/2, x to the 5/2. So if these two are equivalent, x squared times square root of x and x to the 5/2, then 9 to the 5/2 should give us what? 243, because if they're the same, they should have the same value, yes? So 9 to the 5/2 is 243. They are the exact same. Questions on these here? We ready for the next one? Now I will say if it gives you as fractional exponents to begin with, if you're really starting here, go on and add them together. If one of them's a radical and the other is not, With multiplication, you can stop right there. Let f of x and g of x be these here. Want to find f times g of x. Well, f of x in our case is x cubed, g of x is square root of x. Well, x cubed times square root of x is, well, x cubed times square root of x. And really, since this is multiplication, not division, we would leave it here. We can say f of g of x. Now, I will go on and write this the rest of the way out. So x cubed, our square root of x is the same as x to the 1/2. If it was just the cubed root of x, it'd be x to the 1/3, because the number index, or 4th root of x is x to the 1/4. When we multiply like bases, we add. So 3 plus 1/2 would be 7/2. And again, we could do 3 plus 1/2 in the calculator, let it do it for us. Both of these work. I'll take either form. Now, f times g of 4. So we're looking at 4 cubed times the square root of 4. And again, we can plug this in a calculator and it'll tell us it immediately. 4 cubed is 64. Square root of 4 is 2. And it should tell us that the answer is 128. But again, we could have typed this part in the calculator and it would have done it for us. Questions on multiplication? We ready for division? Yes. I'm going to say it because I've been wanting to say this corny joke all day. Yep. Because you've heard this one time and time again. You know I need glasses in math because they can help with division. Because there's so many corny math jokes.
Isaiah would have got a kick out of that. Isaiah would have laughed so hard.
I think they have one. I'll do algebra. I'll do geometry, but graphing is where I draw the line.
It's okay to laugh. You put your paper down.
So these here, we have f of x and g of x, and we want to find f divided by g of x. Well, f of x, f over g of x is the same as f of x divided by g of x. Now, f of x for us is 6x. G of x is x to the 3/4. Now, when we divide these, the first thing we would divide is our numbers. Well, 6 over 1 is just 6. Now, if we had a number on bottom that wasn't, so 6 over 5, we would leave it as 6/5. We reduce as far as we can. Now, when we divide like bases, we subtract the exponents, and it's going to go on top. Well, that would be 1 minus 3/4. Our 1 minus 3/4 would be 1/4. So our f divided by g of x is 6x to the 1/4. That's it. Now we are going to find f divided by g of 16. We're going to take 6 times 16 to the 1/4. Questions on this? Now again, we can do this by hand. The 1/4 is just asking what times itself 4 times is 16. And that would be 2. And 6 times 2 is 12. Or we could say 6 parentheses 16 to the 1/4 in the calculator and give us 12. Questions on these here? Now again, with division, if it hadn't given us 3 to the 3/4, if it gave us the 4th root of x cubed, we would need to change it, rewrite it, change it to x to the 3/4, and then go through the same process. F divided by g of x is the same as f of x divided by g of x.
The joke was hilarious.
So, do you know why they say you need glasses for math? No. Because they help with division. Thank you.
Oh, there was another one.
The graphic one?
I'll do algebra, I'll do geometry, but graphing's where I draw the line.
Can you find these?
Some of these are old.
Oh.
So, f divided by g of x is the same as f of x divided by g of x. Our f of x function is 4x. G of x is x to the 2/3. And again, when we divide this, we'll divide the numbers first. Well, 4 divided by 1 is 4. Now, if it had been another number on bottom, say 3, 4/3 doesn't reduce, we'll leave it as 4/3. Now, our exponents. When we divide like bases, we subtract the exponents. So we'd have 1 minus 2/3, which would be 4x to the 1/3. Now, we don't have it here, but if it had been, say, 4x over 3x to the 2/3, we'd still have the 3 on bottom, the x would go on the top, because we want the x's, these fractional exponents in the numerator. But we don't have that. We have this here.
You got a gun? You got lost it? Yeah.
And lastly, we're going to find f divided by g of 27. So we're going to plug 27 in for x. So we're saying 4 times 27 to the 1/3.
It's not.
Is is 27 to the 1/3 what times itself 3 times is 27? That is 3, because 3 times 3 is 9, 9 times 3 is 27, and 4 times 3 is 12.
I thought it meant like 1/3 of 27.
No, yeah, it was what times itself 3 times. Essentially, it's asking for the cubed root of 27, which would be 3.
Blue, guys. Kaden. You shared it.
Questions on this here?
Oh, wait, okay.
How do we feel about addition, subtraction, multiplication, division?
Great.
Now, the homework problems are going to be a little bit more like this here, in that they're going to give you an f of x and g of x and ask you to find the addition and subtraction with those two functions. Where in the lesson, we took two functions, we added them together, find its value, and then moved on. They're going to ask for addition, subtraction of the two functions. We're not going to do separate each one. And then they're going to ask you to evaluate it for a given value of x. But that's it. And then they'll do the same thing with multiplication. Questions on any of this here? Now, I'm going to show you this here. This is kind of nice, kind of neat, is we can solve or evaluate our f plus g of x, f minus g of x, f times g of x, and f divided by g of x when x is equal to 2 in the graphing calculator. Now, to do that, first thing we'd have to do is hit y equals, and we'll type f of x in first, square root of x. y2 will type in g of x, which is 9 minus x squared. So we'll type both of these functions in. Second quick. Now to do addition, we're going to say alpha trace y1 of 2 plus alpha trace y2 of 2. And we get the value here. Now it doesn't give us the actual form of the equation with x, but it would give us the value. And the reason we're not going to have any homework assignments over this, any problems over this, because all the ones we'll do and we'll have to do, especially part of the test, you have to find out what f plus g of x is, f minus g of x, you have to find out what it is, and then plug it in so it doesn't really save any steps. Because we could say the same thing with subtraction.
When is the test?
Next week.
What day?
Monday.
It will probably be Tuesday.
No.
But that is